Hello. Today we're going to talk about Topic 1, Section 10, Rational Exponents. So, let's see. I think Cognity explains it in this box this way. The best way to do it, I think, is just by doing. So, for example 1, we have 16 to the 1/4. Whenever you have a fraction and an exponent, that means you have a radical. All right, so 16 is the big number, so it's still the big number here. Okay, and how I remember this is since we're dividing by 4, the 4 goes in the index. And the 1 stays as the exponent. So we're dividing by the 4, which is the index. Okay, so here we have the 4th root of 16 to the 1st. Okay, this is also the same thing as saying the 4th root of 16 to the 1st power, right? I'll show you what that means again in the next one, but it just means I can have that exponent inside or outside of the radical. I can do them in reverse order. So here the 4th root of 16 is just 2. Okay? So that's what we want to remember. So let's do example 2. So here, it has a fraction exponent, so it means that we have a radical. It's still going to be 27. We're dividing by 3, so that goes with the division looking thing, right? The radical, I know what it's called, but it looks like the division. Anyway, so then the 2 stays as the exponent. That's the same thing as saying the cube root of 27 and then squaring. That's what I mean by having the 1 on the inside or the outside. Okay? So here, I would much rather take the cube root of 27 as opposed to squaring 27. So the cube root of 27 is just 3, and 3 squared is just 9. Okay? So see how we're able to do this without using our calculator. All right. So the next one. So I don't know what it is. It throws people off with these, all right? So the first thing is this is a radical and this isn't, okay? We can do a couple different options here. This one is the square root. And if you notice, 1/2, that's another way of saying the square root of 3 to the 1st. So we have the square root of 27 times the square root of 3. Okay, so this is actually pretty nice because they're both under the same radical. So then I can just do this. So we get the square root of 81, which is just 9. Okay. Now, you're probably thinking, oh, well, Miss Cross, what do I do if they're not the same radical, right? What if this was a cube root and that was a square root, right? We couldn't combine them. There is another way of doing it. Okay, so let me show you that way. So what you can do is you can notice that 27 and 3 are both powers of 3. Okay, so I can rewrite the 27 as 3 to the 3rd power times 3 to the 1/2. And this square root of 3 cubed, I can rewrite as 3 to the 3/2 times 3 to the 1/2, right? Because in the index of the square root, it's a 2. So 3 divided by 2 is my rational exponent, fraction exponent. And then when I'm multiplying, I add them. So I get 3 to the 4/2, or 3 squared, which is 9. Okay, that's what I mean. That's the one that kids usually don't see, okay? Or adults, right? Really, it's one of those trickier ones. Okay, so if they're in the same radical, super easy, put them under the same thing, combine them. But if they're not, make them the same exponent, okay? Or, I mean, I'm not saying exponent, the same base, right? Okay, so let's do this one. All right, so we want to evaluate what we can do here. Well, 16 and The 3's, well, I can't really combine those, but the 3's I can combine. So I can rewrite this as 16 to the 3/4 times 3 to the 3/2 minus 1/2, right? You subtract the exponents. So we get 16 to the 3/4 times 3 to the 2/2. So that's nice, that's just 1. And then over here, we can rewrite this as the, not quite writing that correct. All right, so a radical of 16, 4 is in the index, 3 is the exponent. Okay, we can also take the 4th root of 16 and then cube it, which I like a lot better. Don't forget your times 3 to the 1st, which is just 3. So here the 4th root of 16 is 2. 2 cubed is just 8. 8 times 3 is 24. Okay, something that looked that gross was able to become that pretty, right? That's simple. Okay, and we didn't even have to use a calculator, right? So knowing your properties is gonna be great here. All right, so let's do this example. So here, I'm going to go ahead and combine what's inside because they have the same base here. So we add the exponents. So we get x to the 2/2, or 1. Okay. Then we get x to the, is 3 minus 1 is 2. Okay. Then we cube it. Just that simple. Okay. Don't overthink it. Follow your rules. Know your properties. Alright, so here I can't really combine anything inside my parentheses, so why don't we distribute my exponent? Now the reason I can do this is because these are all a series of multiplication or division, right? Division is just the opposite of multiplying. So we can distribute here. If there was any adding or subtracting in here, we could not do this. So here we're going to write 32 to the 2/5, x to the 10 times 2/5, power to a power you multiply, all over y to the 5 times 2/5. So that gets us 32 to the 2/5 times x to the, what is that, 4th, and y to the 2nd. All right, I get a lot of kids that want to stop here, but let's try and simplify that number, see if we can. So 32 to the 2/5, that's just the 5th root of 32 squared, or again, the 5th root of 32 squared, which I like better. So we just end up with 2 squared, or 4. So our answer is just 4 x to the 4th over y squared. There you have it. All right, example 3. So here we can go ahead and distribute the 3/4. So I'm going to rewrite that. And since I have numbers, I'm just going to go ahead and write those in radical form. So I'm going to do the 4th root of 16 and then cube it. X, I'm going to go ahead and multiply those. So I'm going to get 15/8. And then down here, I'm going to get the 4th root of 81 and cube that. Then here I get y to the 3/16. Okay, so then here we get, let's see, the 4th root of 16 is 2. 2 cubed is 8. And then the 4th root of 81 is 3. 3 cubed is 27. There you have it. simplest form. All right, some section questions. Okay, so we apparently can simplify this left-hand side to look like this. So put all my a's and b's together. So let's just go ahead and multiply these two things. I'll write this as a fraction. I'll multiply what's on top, so I'll end up with 10 times a squared b to the 3 over 2 over b to the 1/2. Hopefully you know when we divide, we can subtract. So we end up with 10a squared b to the 2 over 2, or just 1, right? So we have 10a squared b to the first. So we line it up with what it's supposed to equal. That's k, a to the n, b to the m. It wants the value of m, so our answer is 1. All right, m must equal 1. All right, let's keep going. So on this one, all right, I'm going to go ahead and distribute the 2/3 to both the 27 and the 8. And then I'm going to write them as a radical. So we're going to have the cube root of 27 squared, the cube root of 8 squared. So hopefully you know these pretty well. Now you're just going to have 3 squared over 2 squared. So our answer should be 9/4. Improper fraction in the form of a over b. 9/4. There you have it. So let's simplify these. So since I'm multiplying, I'm just going to combine or multiply my like parts. So the 2/3 times the 1/6 is just going to be 2 over 18. And then the x's are just going to be 5 over 2 minus 1/3. So I should probably put those in the common denominator. These I can, the left side I can make 1/9, and my exponents are going to get the same, so I'm going to make that a 6. So 15 over 6 minus 5 over 6. What am I doing? 2 over 6? Okay. Yes. So we get 13 over 6. So the answer is 1/9 times x to the 13 over 6. Okay, if you want to write it as one fraction, right, which I tend to think it looks nicer, x to the 13 over 6 over 9. Okay, and that way I know the x goes on top. Okay. All right, so this is what you should know by the end of this lesson, right? With all this, you should be good to go. Of course, I have one extra problem that they didn't talk about in the book, but they do have as a question for homework. So here, going back to our old rules, all right, so we want to factor this. So think about another way of writing 5 to the 2x. Well, isn't that just 5 to the x squared? Okay, so what if I rewrote that differently? What if I wrote it as y squared plus 10y plus 9, right? Let y be 5 to the x. When I do that, I can rewrite that as 5 or y squared and 10y, and then that's a lot easier to factor, right? But then we can't leave it like that because there was no y in my original problem, but there was a 5 to the x. So then I go back and I put my 5 to the x back in, and this is it in factored form. Pretty cool, huh? All right, just another higher level thinking question, which I like. So let me know if you have any other questions or any questions in class.